Hello everyone. This video is part of the series on low-level design fundamentals. We have already discussed the roadmap on low-level design, and we have also discussed the importance of enums. In this video, we will talk about the classes and objects, that the classes are the blueprint and the objects are the actual memory allocation. We'll see it with the help of Java code as well. Then we'll also see the structure of any class or object, and of course again we'll see with the help of code example. Then we'll also see the abstract classes and interface, because there are 4 pillars of object oriented programming. So before talking about them, we need to have some understanding of what is abstract class and interface. So we'll talk about that. We'll also talk how to think when writing any class. So whenever you write a class, you need to think through what should be the superclass, what should be subclass. So we'll talk about these terminologies as well, and a bit about the interfaces and the UML diagram. So let's quickly get started. What is class? Class is a way to structure your data. For example, if you want to describe a dog, so dog would have a certain sets of properties like name, color, and there are a few actions which a dog would do. For example, bark. So whenever you want to collect a set of information, then you can use classes. Classes are the blueprint on how the data would be stored. The data is stored in the form of object. So for example, if you define a class, say class name a dog with name and color, so the memory will not be allocated for the class, but just a blueprint will be defined. So it is just a way of telling that this is how my data is going to be structured. We have not yet stored the data. We are just telling the runtime environment and the compiler that this is how my data is going to be structured. Coming to object, this is where the actual data lies. So if you see an object, you would have the actual properties. For example, the color would be red and the name can be Max, and the object can have a bunch of actions as well. For example, barking. So this is the actual data, whereas the class was the blueprint. Now let's see what would the structure of any object or class look like. Why I mentioned both object as well as class? Because the classes are the blueprint of the object. That is, the class would define the structure of the object. So this is how any object would look like. That is, they would have name. They would have some instance variable. That is, let's say name of the dog and the color of the dog, and some behavior. That is the verb part. So there are 3 parts. The first is the name. The second is what it knows about. So any object would know about themselves, that is their own state, in this case name and color. And the third is what the object does, that is the verb form, that will be the function. So any class is composed of 3 things. The instance variable. So the instance variable are the state or the things which object knows about. And the second is the verb form. The first one was noun and the second one is verb. So this is how an object is composed of. So the first one is quite clear, that the data would be stored in the memory. That if you create an object of class dog, it will have name as, let's say, Max, and the color as pink or red. The second part is the method, the function name bark, where there will be a few lines of code you would have written, like system.out.print, or you would be fetching some values and doing some stuffs. So a method is nothing but a set of instructions. So while the knows part, that is the state part, is separate for all objects, the method part is shared among all the objects. So now let's quickly move on to the code example to see how the objects are declared. The same stuff you can see through code as well. So I have already written a code. You can see that I have a public static void main method. I have the class name as dog. And again, if you see, there are two properties. In fact, three properties. First is the name of the class, which is dog. The second is the instance variable, or the thing which the object knows about. So object knows about two things, name and color. And the third is what the object does, which is the function name. So here the instruction or the set of instruction given in the bark method is system.out.print something. And this is how you declare the object, and you can set the properties, you can set the states, and then eventually you can call the function name. And you would already know about the output, and this is how you can see the output. So if I run it, yes, dog name Max of color red is barking. So this is how you can print the statements and you can initialize the object. Now let's talk about the abstract classes and interfaces. There are a lot of different types of classes which can be created, but I'm talking about just two of the things. One is the abstract class and the other is interface, because this is a bit important to understand before moving into the design part of it, or before understanding the pillars of object-oriented concepts. So abstract classes and interface, they will generally be talked together because in most of the cases they behave similarly. There is just one of the cases where the abstract class would behave differently compared to the interfaces, but in all the other cases it will behave the same. So they are just like classes. They are the blueprint of objects. So the same state and the verb part, they are same for both abstract classes and interface. However, they cannot be created the way the objects would be created with the help of class. So when we were talking about the simple class, you could write a statement like new animal. But if the animal is abstract class, you cannot do that. So this is the difference. Now let's say we have multiple classes. We had a problem statement where we had to create multiple classes. Say those classes were cat, dog, and horse. For example, for this one, we are just talking about what these people do. So dog would be born, then it would die. In between, it would make sound or it will walk. Likewise, cat would be born and dead. And in between, it would do a bunch of things. Likewise, horse. So let's imagine that the first method and the last method are same for all the dogs and horse and cats. Here, two different things come into the picture. The first is the commonality part and the other is the variability part. So remember, whenever you are writing any class or whenever you are writing a set of classes, it's important to think through in terms of commonality and variability. So let's say these are the two things which are varying across the classes. So make, sound and walk would change for all the three classes, but the first and the last one would be same. So the first and the last will be commonality, and the second and the third would be the variability among the classes. So once you decide that, it is better to move the commonality part or the common part to the common place and the different part to the different place. So let's see how it will look like. So if you see, this is how our classes were there. That is three different classes having different methods. What we did was we moved the common things to the common place and we moved the different stuffs to the different place. Why we did that? We did that so that we make less mistakes in the code. So whenever this born method or the die method changes, so for example, here we figured out that the born and the die method would be same for all the animals. So it was better to move it to the common place. Here we moved it to the other class called as the animal class. We will create a method named as born. We will create a method named as die. And then we will write the set of instructions or the whole function definition in this particular method of born as well as die. The different part, the thing which is different, will move to the subclasses or the different part. We'll talk about this subclass and the superclass, but the short definition is that cat is an animal. So cat would be subclass of animal. Horse is a animal. So horse will be subclass of animal, and likewise for dog. So all the different part, all the things which change, that is the variability part, will come in the subclasses, and the common part will come in the superclasses. And the superclass will just have the definition here. I'll come on to the part where, how it is different or the same when you see the code, but you can see that the subclasses have the variability part and the superclass has the commonality part. We initially talked about the abstract classes in interface, and we will talk about them synonymously. And whenever possible, the first suggestion is to always use interface. There would be very few cases where you would be using the abstract classes, and we'll talk about them in the details, but in most of the cases, you will come across the interfaces, and very few cases it will be about the abstract classes. And yes, the class can implement multiple interfaces, but it can inherit only one abstract class. So let's quickly move on to the coding part so that you can visualize what we are talking about. This is our code. So we have a class. This is our main method, public static void main, and we are doing a bunch of things, and we'll observe what we are doing. So the first thing is we'll talk about the interfaces. So how you declare interface? You declare interface with the help of keyword called as interface. Then we talked about the behaviors. That is, what does the object do? So we have defined 4 different methods here. The first is the born method. That is, the animal would be born, and as soon as the animal is born, it will say I am born. And whenever it dies, it will say I am dead. And in between, it will do 2 things. It will walk and it will make sound. That is the only mission of its life. So this is how the interface would be defined. But remember, you cannot create an object of the interface. So if I write something like this, I would not be allowed to do that. It will give me error that it's an abstract, so you cannot instantiate it directly. So what I had to do is I have to create a class whenever I want to instantiate. So whenever I write class cat, implement animal, then I need to implement these 2 methods because these are the variability part. That is, these things are varying. The common part are written in the superclass thing, that is the interface. And here I'm just writing the variability part, that is the walk and the make sound. So there were 4 things: born, die, walk, make sound. So it came under the variability part, that is, in the subclass or in the lower layer of the class hierarchy. And the other thing was on the top. So this is how you declared it. And while instantiating, you can just put new cat. Now the animal would be born, it can walk, it can make sound, and it can die. And when you do that, the runtime environment will take care of everything. So runtime environment will pick the implementation from here, I am born. Then for the walk, it will say where I can find the walk statement. It will print from here. Then it will see the make sound, that is, it will print from here. And the dead part, it will print from here. There was one more thing which I mentioned, that the abstract class and interface, they are pretty much same. So what I'll do is, this is the interface. I'll just change it a bit to interface, and you will see it just works the same. So let me quickly do that. And I'm done. You can see all I had to do was to change a few keywords and I was good to go for the interface. That is, I still have the born method. I still have the methods that need to be implemented by the subclass using the extend keyword. And my main method has remained untouched. So if I run this code, I will get the same output. You can see the same output is there. So that's why I was saying that the interfaces, the abstract classes, they work exactly the same. And in most of the cases, you will be in a situation where using the interface would be better. So that's how it is, that use interfaces whenever possible. But if there is a special case, which we'll talk later, then you can touch upon the abstract classes. But most of the cases, you will be good to go with the interfaces. So summarizing it visually, if you see the way interfaces and abstract classes are there, so both of them are almost same. So this is how we represent an abstract class. This is a UML diagram. And in the UML diagram, we represent abstract class in italics. And the interfaces we represent in this way. And then this is how you represent all the methods. Here it was born, but in interfaces, you have to write a keyword as default. And then you have some of the methods that needs to be implemented by the subclass. So here the method name was enough. Here you have to put abstract keyword, but the subclasses were same for both. So it's just a matter of a keyword thing. One major difference is that the subclass can implement multiple interfaces, but it can extend only one abstract class. So that's the only difference. So abstract class sort of makes you restricted compared to the interfaces, which gives you more freedom. So that's the only difference, and that's why you prefer more freedom. So you go ahead with the interfaces. So that brings to the end of the video. In this video, we talked about the classes and objects. We saw the structure of the class, how the class looked like, what are the states and the behavior of the classes and objects. Then we talked about the commonality and the variability part. This will be extremely important when designing a low-level system. So we'll keep that in mind. And we also talked a bit about the UML diagram. Just to clarify, the UML diagram which we are talking about is a simplified UML diagram, the one which we need for the class diagram. So this is what we are going to talk about. So that's it from my side for this video. I'll post more videos in the coming weeks where we'll get into the slightly advanced topic. So till now it was covering the basics, covering the pillars, that how would the object look like, etc. And these are very important. So thinking in terms of commonality and variability is important. So that will help you to decide when to have a superclass and when to have a subclass. And there are other use cases as well, but we'll talk about them in the coming videos. So keep watching and subscribe to the channel. Till the next time, bye.